Imagine waking up in a world where your phone unlocks with just a glance, or where a camera can gauge your mood without you speaking a word. This remarkable future hinges on deep learning technologies, particularly convolutional neural networks, CNNs. At first glance, it seems complex, but let's simplify the process of how these systems see and understand faces. CNNs are specially crafted neural networks designed chiefly for image processing, working their magic by identifying intricate patterns within those images. Consider how humans perceive a face. Our brains do not instantly recognize each aspect, but instead break it down into smaller features such as the eyes, nose, and mouth. In parallel, CNNs mimic this approach. When they analyze an image, they decompose it into smaller sections using filters that dynamically slide across the image, scrutinizing basic patterns such as edges and curves. These filters are adept at extracting vital features at a granular level. The early stages might identify simple lines, whereas later layers combine those elements into recognizable facial shapes and characteristics. How does a CNN acquire its skills? The process unfolds through meticulous training, involving exposure to thousands or even millions of facial images. Each time a CNN attempts to identify whether an image includes a face, it receives feedback via a mechanism known as a loss function. Envision this loss function as a teacher, correcting a student's mistakes. If the CNN falters in its prediction, the loss function quantifies the error and advises on how to realign its understanding, fostering an environment of continuous improvement. There are various loss functions tailored to specific tasks. In the case of facial recognition, which involves pinpointing specific individuals in a photo, classification loss takes the spotlight. This loss function evaluates the accuracy of the CNN's predictions while penalizing the network for inaccuracies, motivating it to enhance its performative skills. When predicting characteristics such as age or emotion, regression loss comes into play, assessing the closeness of CNN's predictions to actual metrics and enabling continuous adjustments. As CNNs collaborate with loss functions, these machines evolve from merely detecting faces to gaining a profound understanding of them. An adept CNN can discern emotions like joy or sorrow by recognizing patterns associated with these expressions, quantifying details such as the curvature of a smile or the tension in a frown. This nuanced capability makes CNNs an invaluable asset across a plethora of applications beyond basic face detection. The significance of this technology is monumental. Its purposes span across various fields, from enhancing security by replacing traditional passwords with facial recognition, to revolutionizing healthcare by analyzing facial cues for diagnostics, leading to more accurate and personalized medical care. Once seen as futuristic concepts, the capabilities driven by CNNs are now reshaping our everyday lives.